The third characteristic of a polynomial function, the polynomial function has x-intercepts, and it could be 2, it could be 3, it could be more. But it has the x-intercepts. Characteristic 4, the graph of the polynomial function often has turning point. So the turning point is determined from the highest degree power term, the highest degree power number, highest in, okay, this is a degree number. Highest degree number to -1. That would be the turning point. So when I have a polynomial function is x, the highest degree power is 5, that means this curve, the graph of this function has a 4 turning point. So you have 1, 2, 3, and a 4. So we have 4 turning points of the x degree power 5 polynomial function. How do we find the zero of the polynomial function? By factoring. So finding the zero, that means you are looking for the root. So it could be you are looking for the roots, right? You are looking for the result. You are solving for x, in other words. The function f of x represents a polynomial function. Then the solution or roots of the polynomial equal make the function tend to 0 are known as the zeros of the polynomial function. So in order to find the zeros of the polynomial functions, we have to set the function equals 0. So that means within the x cubed plus 4x squared minus x minus 4, we set the function equals 0. Now, if you look at this function, it has 4 terms. So with the 4 terms, we cannot do the factoring, right? So only way we can narrow down this function, or simplify this function, we do the grouping. So when you have 3 terms, when you have the x squared plus x minus 1 equals 0, we do the factoring, right? Finding the factor form and solve the x from there. When you have 4 terms, we need to do the grouping first before you move on to finding the factor form. And normally we group the first 2. If the first 2 doesn't work, you group the other 2. And sometimes you have to practice that several times in order to find the right pair to group them together. So when I look at these 2, I know I have the common factor among these 2 is x power 2, right? X power 2 is the common factor of these 2. So I'm going to take out the x power 2 to the outside. Now the first term, once the x power 2 bring to the outside, I still have the x term left. The second term, take out the x squared, I will have the 4 left. Now we group the other 2. Because the sign in front of x is the negative sign, so I have to keep the negative sign in the between here. Now open another parenthesis, minus x, right? That's what it was. So minus x. Now the 4, since the 4, we squeeze the 4 into the inside of the parenthesis here. And the outside of the transition sign, this is a negative. So in order to make the 4, when we remove the parenthesis, it will keep the sign is a negative sign. We have to make the change of this sign turn to the positive when we keep the 4 inside to the parenthesis. So once you distribute it, you'll get a negative x and then negative 4. Now set that equals 0. the next step is take out the common factor one more time. So when I look at these two terms, I realize I have the common factor of x plus 4, x plus 4. So now we take out the common factor one more time, is x plus 4. Once I take out the x plus 4 to the outside, the first term, it still has x squared left, right? So once the x plus 4 take out to the outside, we open another parenthesis right away. There's no plus minus in the between here, no longer. Okay? When you move on to take out the common factor second time, there's no plus minus sign in between. Now you just fill in the x squared minus x plus 4. It has bring to outside already. So the second term here, everything reduced, but you still have the 1, right? This is a 1, so minus 1, you close it, so that equals 0. Now from here, we can solve for x by using the zero factor theorem. So here, we let the x plus 4 equals 0, which is x equal negative 4. This factor form here, we have x squared minus 1, so I can simply set the x squared minus 1 so that equals 0. Bring the 1 to the right hand side, we get the x squared equal 1. Take the square root on both sides, we get an x equal plus minus. Square root 1 is just 1. So we have three solutions. One is x equal negative 4. Another two solutions are positive negative 1. Highest degree power 3 indicate this function, this polynomial function has 3 roots of the x value. So the 3 roots, they are coming from here. Okay, so now determine the end behavior. A basic polynomial function we call a power function. It's a polynomial function of the form of f of x equal axn, only single term. We call this as a power function. Where a is a real number, a cannot be equal to 0, n is a non-negative integer. So this is just give you an idea. The basic function of the polynomial function. Now, under the polynomial function or under the power function, we call it a family function, right? So it has that the structure of the different type of the graph. So we just refresh this part real quick. The first function, the parent function has f of x equal x, which is your y equal x. This is the same meaning. So this is a linear. You have a straight line passing through the 0, 0. The basic function of the power 2 function, we call this is f of x equal x squared. So this is the same meaning you have a y equal x squared, f of x. We call this as a quadratic function, the parent function of the quadratic function. So the parabola passing through 0, 0 is facing a parabola because we have a positive x squared. River, this is a river. It passing through 0, 0. We call this as a power 3, x power 3. It's a cube function. So this is a cube. The first one is a linear. This one is a quadratic. So the river, the cube function, it starts from quadrant 1, passing through 0, 0, and then drop down on quadrant 3. This graph, we call it a powerful function. So f of x is equal x power 4. So this graph is very similar like the quadratic function, but when the curve comes near to the x-axis, it's more flat. Because this 4 indicates it has 4 solutions. and that's why the curve has more touches with the x-axis here. So I just call this as a powerful function.